Good people. Welcome to JJ Tech Tutoring. Today I will be taking you guys through this kind of equation. I'll be solving this differentiation for you. First thing first, we need to understand that this inverse of this is equals to 1 over 1 plus x squared, right? This is the answer. So when we derive this, we get this, right? So now we are given something like this. So what is it that we can do to end up here, right? Because the question is ensure that the derivative of this is equals to 1, right? Now, what we have to do now is to use u substitution, right? We need to say, okay, let u is equals to cos x over 1 plus sine x, right? Now, right, so now from that we can now derive this, but then we will be deriving what? We'll be deriving arctan u with respect to x. We'll be deriving arctan u with respect to x. So what is it that will happen? We are going to derive this implicitly, right? We're going to have 1 over 1 plus u squared, right? Then du over dx, right? Because we are deriving this with respect to x implicitly, then we have to get something like this, right? Now, we must now get our u, right? So now we are going to derive our u. So our u is equals to cos x divided by 1 plus sine x, right? Now we have to derive this. So first thing first, we can use u substitution or t substitution, or in this kind of equation, we can still use quotient rule, right? We can still use quotient rule, right? Now, the derivative of this is negative sine x, then multiply by this cos x, right? Minus the derivative of this. Actually, here we have to multiply by 1 plus sine, right? 1 plus sine, because we take the derivative of this and multiply it by the original this, right? And then this side we take the derivative of this and multiply it by the original this. And then you can still go and check the other videos that I uploaded when I'm teaching the quotient and then product rule, right? And many rules to integrate, to derive, right? Then the derivative of this is just cos x, then multiply it by the original this, right? Then divide by 1 plus sine x squared, right? Divide by sine 1 plus sine x squared, because we have to square the denominator, right? So now let us just try to simplify. Right, now we need to factor out negative, and then we'll have sine x minus plus sine square x plus cos square x, then divided by 1 plus sine x, right? So with this you can see that I've now obtained something like this, which is 1, right? Something like square identities, which is 1. So now we have to now have minus sine x minus 1 divided by 1 plus sine x all squared, right? Because we replaced this by 1. Then from there we multiply it throughout by negative. So it's negative sine x negative 1. Then that's it. That is our du over dx, because we're deriving it. So this is our du over dx, right? So now going to the equation itself, going back to our this particular thing, we need to now then say dy over dx, then it is equals to 1 over 1 plus u squared du over dx, right? So now we have to say y 1 plus, instead of putting u, we have to bring back our cos x 1 plus sine x all squared. Then multiply it by negative sine x minus 1 divided by 1 plus sine x all squared. Right? So now we need not to complicate things, right? We need to now come to this one and simplify. And simplify. Then by simplifying, we just have to come and say what? We're going to simplify the denominator, right? Let us take the denominator and simplify the denominator first before we can just complicate things. Right. So first thing first, we have to cos x squared divided by 1 plus sine x whole squared. Right. Then from there, we can now do the fraction. We leave in the common highest common denominator. Right. Then from there, then we can say this one goes, then we just put this here, plus sine x squared, right? Then plus cos square x, right? Then from there, we need to do what? We need to simplify the numerator because it seems complex. So we can just take the numerator down here and say 1 plus sine x, 1 plus sine x plus cos square x, right? Then from there, we have to start expanding it. We are only on the numerator. When we are done with it, we're going to put it on top of this, right? So worry less about it. Now, 1 is to this 1 plus sine x plus sine x plus x squared plus cos square x, right? Then this one is 2, then it's 1 plus 2 sine x plus sine square x plus cos square x. Right. So now this one is our 1 because it follows the identity, square identity, right? So it's going to be 1 plus 2 sine x plus 1, which is 2 plus 2 sine x, right? Because now we have added this and this, right? So don't forget that this was just our numerator. This was just our numerator. So we are going to take this back there, right? We are going to take this back there. So it's going to be, that means 1 plus cos x, 1 plus sine x. That means this is equals to what? 2 plus 2 sine x over 1 plus sine x squared, right? So don't forget that this was here. So we are done solving it. We have to put it here, right? So now when we put it, when we take it back here, it's going to be 1 over 2 plus 2 sine x over 1 plus sine x squared, right? So now we can just get rid of the first division or this numerator. Then they're gonna spin. Then we will have 1 plus sine x squared over 2 plus 2 sine x, right? So this is how it is, right? So now let's go back and solve our dy over dx is equals to, then it is equals to this because it was initially equals to this multiplied by this, right? So now it's going to be 1 plus sine x squared divided by 2 plus 2 sine x, right? Multiply by this, right? So multiply by negative sine x minus 1, then divide by 1 plus sine x all squared, right? All squared. Now what we have to do now is to manipulate, right? We have to manipulate this part. Okay, first thing first, we're going to cancel this because they are the same, right? Then we're going to have minus s minus sine x minus 1 divided by 2 plus 2 sine x, right? Then from there we're going to have to factor out negative 1, then we'll be left with sine x plus 1, right? Then we have to factor out what? 2, then we'll be left with sine x plus 1, right? This is how it is, right? So here it's commutative. You can start with 2 or you can end with 2. Here it's commutative. We can start with 1 and end with sine x. So it's one and the same thing. So we cancel this. So that means our final answer is -1/2. Then it is proved. It is proved because we're supposed to prove this. Actually, the question actually had -1/2. So this is how it is. This is how it is. So just follow for more or subscribe for more content like this. So automatically you now understand this kind of a question.